All right, let's discuss the second problem. Evaluate the line integral where C is the arc length, arc of the parabola. Okay, y equals x squared, and from 0 to 1. Okay, so in this case, all you have to do is you have to find the parameterization. Okay, the formula we are going to use is if you have a function f of x, right? So this is a function, right? And then the formula will be from a to b f of x over t, y over t, but the ds is going to be x prime t squared, y prime t squared, and dt. Oops. Right, then dt. All right, so you have to find parameterization. There's the most natural parameterization for the parabola is going to be x is t, y equals t squared. T is between 1 and between 0 and 1, right? Then that's it. Then the integral cx ds is going to be from 0 to 1. X is replaced by t, and then the derivative of x is going to be 1 square. It's 2t square and dt, right? Yeah, the derivative y with respect to t is 2t. Okay, so this is a formula. Okay, and you only get most of the credits if you can write down such details. Okay, and if I worry about other problems, my suggestion is stop here, move on to the next problem to look at the next problem. So that can sometimes it takes more time. If you think it's easy to figure it out, then you continue. Otherwise you should move on to the next one. Okay, and for this one, I already see that this is going to use substitution. So you let u to be 1 plus 4t squared. Then du equals 8t dt. Then this definite integral will be when t equals 0, it's 1. When t equals 1, it's going to be 5. And this is the u to the 1/2. T dt is going to be 1 over 8 du. Okay, right? Yeah, change everything to u, including the interval. Okay, then the antiderivative of this is going to be 3 over 2, u to the 3 over 2. Evaluate at 2 endpoints. This is going to be 12, and 5 to the 3 over 2 minus 3 over 2. So that's the answer. Okay. If you still have trouble to figure out how to evaluate, then give up immediately to move on to the next problem. Okay. So this is this is called a line integral. Now, sometimes the line integral involves, you can even apply the Stokes theorem, okay? And then in that, so it's not necessary, if the curve is a closed curve, in that case, you have two options using Green's theorem to evaluate the line integral, or you can just use parameterization to evaluate directly by the formula I just mentioned above. Okay? The two options. So it's hard to tell which one is better. Okay. So the second problems, so the second problem will be the line integral here, c y d x plus y squared dy. Okay. And this time C is the closed ellipse 4x squared plus 9y squared equals 36 with counterclockwise orientation. Okay. All right, so then you have the things, this is a closed curve. Okay, you have the it includes a domain D. So remember, you can use a Green theorem to solve the problem, right? The Green theorem says that the line maybe does not work for this one for ellipse. Okay, so here px plus q dy, right? The Green theorem says that it's going to be qx minus py and dA, right? So sometimes change the double integral will be much easier, especially when the closed curve consists of several pieces. That indicates more likely you have to use a Green theorem because you have to parameterize for each pieces, right? That would be triple your labor. You know, you have to spend more time to evaluate 3 integrals or 2 integrals, right? So more likely you are going to use a single double integral, especially like a square. If the closed curve is a square and or circle, you know, right? Square, for example. If you want to evaluate the line integral on the square, how many pieces, right? The 4 pieces there, right? So that takes too much time. So you really should jump to, yeah, you have to use this Green theorem to do that, okay? Yeah, circle. Now, ellipse, I'm not sure because the double integral over ellipse, elliptical domain, we call it elliptical domain, maybe not easy. Okay, so let's try this. Okay, that's going to be that's the first method, right? And this is domain D. Qx is going to be x plus y squared, right? Minus okay. It would be very surprised to me. It's going to be 0. Okay. So it's 1 minus 1 dA. It's going to integral of 0. So to some students, maybe only take 2 seconds to solve the problem, or 5 seconds. If you want to parameterize the ellipse, right, and use the first method to solve the problem, it took 10 minutes maybe. So you have to decide which method you're going to use. And I just say I try, especially when it's a circle. Then the double integral over the circle is very simple. Double integral, you know, if a rectangle, triangle, maybe is our simple. Okay, so you should think about the Green theory. Okay, so you're not told which method you're going to use. Now, if you don't want to use Green theorem, and how much time you have to spend, right? So first of all, you have to parameterize the ellipse, 4x squared. 4x squared plus 9y squared equals 36. You should know how to, right? Parameterize it. It's going to be x squared and 36 over 4, right? Y squared 36 over 9, right? So we rewrite this again. It's going to be x squared 3 squared here, y squared 2 squared. I think it's 4, right? So the parameterization for the ellipse is going to be 3 cosine t, y equals 2 sine t. No problem. So that is going to be t is between 0 and 2 pi. Okay? Then the line integral becomes, let's see how difficult it is, right? dx plus x plus y squared dy. Right? This is going to be the integral from 0 to 2 pi. Y is going to be 2 sine t, right? dx will be negative 3 cosine t, and x is going to be 3 cosine t. Y is going to be it's here y squared is 4 sine squared t, and the dy is going to be 2 cosine t, right? And then dt, right? You will see that maybe you can evaluate. No, that's not. Yeah, that's there. So maybe you can evaluate this integral, but takes too much time. So you are going to get -6 sine t cosine t and plus 6 cosine square t plus 8 sine square t cosine t and dt. Okay. I think the first term is going to be 0. The second term, yeah, it's not too bad. Eventually, you're going to get 0. Okay. It's good exercise to evaluate this integral, but I tell you, takes to some of you takes about 10 minutes. Okay, you're going to, or 5 minutes, you know. Yeah, it's not a guarantee you're going to get the same answer. Evaluate this integral. Okay, so I guarantee this is going to be 0, but you can complete it. Okay, the first part is going to be 0. The second part, they have an opposite signs, I'm pretty sure. Yeah, use this is the third one is a substitution. All right, so I stop here, but that method works, but takes more time. Especially remember, so that's why when you study, you have a notebook, you have some summary of the ideas you learn experience, right? You write down that, then you will put that. If it's line integral, if it's closed interval, it's closed the curve, right? Then there's the two methods you can use, Green's theorem, and then change it to the double integral. But especially when the closed curve is, consists of consists of pieces. It's more likely you're going to use a Green's theorem to solve the problem, okay? Or it's a circle, right? Well, fxy is going to be xyi plus xj. And c is given by all right. So this is look at the curve. It's hard to draw it, right? It's the curve is already parameterized by this function. Okay. So you have a starting point, you have an ending point. Okay, the starting point is going to be when t equals 0. It's here. Okay. This is I, this is j, or x, y axis, doesn't matter. So when t equals pi, x is still 0, but this will be 1 plus pi. So I guess this is a curve like that. Okay, from here to here. All right. So how do we solve the problem? Right, we use parameterization. This is a formula you can get. And is there any other method can solve the problem? Now, if the vector field is conservative, yes, you can use so there's a second possible way to solve the problem. The first one is use a formula, right? By the computation, it's going to be it's from 0 to pi, right? F x of t, y of t, right? And then here, this is going to be r prime t, so x prime t, y prime t, dt. So that is dr, okay? Right? So you can see x times y will be sine t times y, 1 plus t. Right? That's the first component. X squared will be sine square t right? And then the dot product has cosine t and the 1 and dt. Let's see if this is a complicated integral. This is 1 plus t sine t cosine t and then plus sine square t dt. Yeah, it's not too bad, but it's complicated, right? You can evaluate, no problem. Yeah, but you have to make sure the formula is correct. We will check each step, you know, right? And if the answer is wrong, I see where's the computation mistakes. Somewhere, maybe the derivative is wrong. Maybe when you multiply this out, right, you get wrong answer. So sometimes, yeah, when you're trying to evaluate this integral, and for some reason, you know, you make mistakes. So so this, yeah, you can evaluate. I'm not going to do that. Okay, this is from calculus 165. You have to use the integration by parts, and you have to use a formula sine squared t equals like a 1 minus cosine 2t multiplied by 2, right? So that works. Now, is there any other method we can use? Well, if f is conservative, okay, on R2, okay, so that's a two-dimensional. Then what happens? So that happens. So this is a gradient of f, right? So actually, this becomes the integral. This becomes the integral from 0 to pi. Okay, this is from 0 to pi, the derivative of f. Okay, by the fundamental theorem of calculus, it's going to be it is only going to be the 0, the value of the two endpoints. Right? You only have two endpoints when t equals 0, it'll be 0 and 1. When t equals pi, it will be also sine pi 0, so 0 plus 1 over pi. So actually, it's going to be f of 0, 1 plus pi minus f of 0 and 1. So all I have to do is just find the function f. It's nothing to do with the past. Okay, just the end point. So take a look at that. The capital F is going to be, now what is capital F, right? That's not sign. Okay, a capital F is just x, x times yi plus x squared j. I'm just trying to see if it's work, right? So that means partial derivative of x is going to be x times xy. Now before I do that, I can check whether this is conservative. Not sure. Okay. If it's conservative, what you can see. So if it is conservative, then qx minus py is going to be 0, right? Yeah. So I think it's not conservative unless I change the sign. Okay. So for this problem, there's no way to solve for YF. Okay. If you try, what you get, okay? What you get is, look at that. If you integrate with respect to x, you get half of x squared y plus constant depends on y. Then I put into the second equation, I get half of x squared, right, plus c prime y equals x squared. Then no solution because it depends on x. Okay. So no solution. Okay, no solution. So that means f is not conservative. F is not conservative. So there's no other way you can solve the problem. However, I just say that if f is a following function, how do you know that before you solve the equation, right? So here the theorem. Okay, if f is going to be p q, right, on R2, on some so-called simply connect domain, but just let on 2, okay, on whole R2, okay, whole plane, or some nice domain without whole, okay, and then f is conservative if and only if qx minus p, otherwise it's going to be 0. So now for f x times y x squared, this is not going to be conservative because qx minus py is going to be 2x minus x is not going to be 0. Okay, so this f is not conservative. You're not able to even solve it. But, okay, but if f is going to be 2xy and x squared, okay, then it is conservative. Okay, not only that, you will get x squared times y. Okay, in fact, this is going to be greater than f, and f is going to be x squared times y. Right, then doesn't matter what curve I'm going to give to you. The line integral, yeah, for this one. Okay, so here's an exercise, right? Evaluate the integral c f star and dr. Okay, and c, I can make it complicated. Right? C, I can say that, okay, C is this triangle from here to here, right? Something like that. Okay, so in that case, this is going to be, 0. This is going to be 1 and the 1. Here's 2 and 0. This is 0 and 0. C is just this curve from P to Q, right? To here. That's a C. So if you want to evaluate this line, then you have to parameterize each line, right? It takes too much time. Now, first of all, you have to say that this is a conservative. Since it's conservative, then since f is greater than f, where f is x squared y, then this line integral is just the value of the function at 2 endpoints. Right? Then it becomes very simple. It's going to be and 2 squared times 0 minus 0 squared times 0 is 0. Right. All you have to do is just find the little f. It is going to be independent of the path. Just depends on the value of the little f at the 2 endpoints. Okay, so this is good. So look at when you're given very bad curve, okay, and look at the f, whether you can prove that it's conservative or because it's much easier to find the gradient for that. Then evaluate the line integral using a traditional method. Okay. Yeah. So some students ask me what is the meaning of this line integral? The meaning of this line integral, the physical meaning of this line integral. Suppose you have a curve in the space. It's not necessary. It's in R2 or R3 or any dimension. Or it's hard to imagine, right? So there's a vector field in the space. So that can call the force. F usually means the force. Okay. So like a wind blows there's object. It can only go around this orbit. Okay, this is the only path this object can move. Okay, assuming there's no friction. Okay, so you can push the force, but if the force direction is in that direction, but the tangential force, the actual force acting on the object is tangent to the object. Okay, so the force actually, the actual force is F times the unit tangent vector, the dot product. It's a projection of the force. That is the length of the projection. So then this integral little ds is going to be line integral of the vector field. Okay, this actually is going to be the work done. Okay, the work done by moving this object from along the curve by the force F. Okay, so this is called work done by the force field F. Okay, in moving the particle from P to Q along the C. Okay. Along the curve C. Okay, so that's the meaning, the physical meaning of this line integral. Okay, of course, if you know how to parameterize it, if there's this parameterization R of T, then this line, this integral is going to be usually tradition is written in this form. So dr is just this part is just dr if you know the parameterization. Okay. Oops, where's my? So our next problem is to show that this force field x, y, z equals sine y I x cosine y j minus sine z k is conservative and find the f such that this is a greater than. Okay, now there are two ways to solve this problem. If you just want to prove this conservative, you need the theorem. Okay, the theorem says that on the whole R3, it is conservative if only for the curve of the vector field is 0. But if you have to find the f, then why not just find f directly? If you're able to find that, then means it's conservative. You prove the statement at the same time, right? Right. So right now we just say, yeah, here's the theorem. I just record the theorem, okay, on the whole R2, R3, okay. F is conservative if and only if the curve of the vector field is going to be 0. Right? You can, if you just want to prove it's conservative, use this theorem. Okay. Sometimes before you try to find the this little function f, little f, you also want to check whether the curve of the vector field is 0, because but in this case it's not practical because takes too much time to compute the curve of the vector field, right? It's not simple like a q sub x minus p sub y equals 0 in the green theorem. Right? But anyway, let's prove that using this theorem first, and then we try to find out. Okay, but I said that we can skip that step. So curve of the vector field, if it's 0, only guarantee you should find the little f. Okay. Because you know that by the theorem, so it's going to be 0. So this is going to be ijk partial derivative I only memorize this format, you know. The details of expansion, it's not clear. It's hard to memorize. Okay. Most of it was you know, it's biological brain, you know, like it's hard to memorize all the details. But this formula have like a shape here, you know, all logic, IJK. Okay. So first of all, you get 0. I think it's already 0. I minus, it's also 0. Okay. Then plus partial derivatives cosine y minus cosine y. Okay. Okay. So it's 0. Okay. Just quickly can check that. It's going to be 0, 0. If you know how to expand the determinant. Okay. Okay. You just expand the determinant along this first line. Okay. One by one. All right. So it's guaranteed there is a little f. So you have to solve the problem. Now solve the equations. It's going to be sine y, x cosine y, all right. Now let's try and solve it. All right, how do you solve it? Sometimes you can look at this result, you can by guess and try, but this time I'm pretty sure sine y is there. Okay, I even can tell there's x there. Okay, and so I can even write down the answer quickly. It's going to be x. Oops, that's the problem. Come on, please go away. Okay, so x sine y plus cosine z. I can tell that. Okay. Yeah, you can solve this step by step, but this is a function you can get. Integrate the first one, right, with respect to x. You know, you want to get sine y, so x times sine y. When you differentiate with respect to x, then you check the second one, and when you differentiate sine y, get a cosine y, so x times cosine y. And the last one you get, you want to make sure its derivative with respect to z is negative sine z. That should be cosine z. So just add them together. Okay, just add them together. So this is a function. So you're done. Okay. So the idea is just evaluate as integrate. Okay. Then you have f. There's x sine y plus c depends on y z, right? Then you put into the second equation. It's going to be x cosine y, right? And this is going to be x times cosine y. And then this is supposed to be 0. That means c is independent y. So that implies c is just c of a z, okay? Then you put into the third equation, and because f is going to be x sine y plus cz, right? C of z, and you put in the third equation, it's going to be 0. And this is negative sine z. And then you solve for c. Okay, c is going to be cosine z. Okay, then you solve the problem. Okay, you find the c. Okay, so f is going to be x sine y plus cosine z. And plus constant. But that's okay. Right, so this is a function. And now if you can see this is a conservative, then if I give you very complicated curve, it's easy to solve the problem. Okay, so if I ask you to evaluate this integral CF dot dr, right? where f is the one I already gave to you. Okay. Now the C could be very complicated. Let's just assume it's a semicircle, or even make it more complicated. Yeah, just assume it's a semicircle. Okay, from here to here. Okay, and x squared plus y squared. No, it's in the space. So space. Let me give you another example. Okay. So C is the line segment from any point, right? From 0, 0, 0 to 0 pi, 0 pi, yeah, 0. Okay. Well, this is just a line segment. Okay. This could be 0 pi. Yeah, I'm going to put a pi over 2 here. Okay. All right. So for this problem, right, if you use a traditional method, okay, then by definition of the line integral, then you have to find the parameterization, right? And then you use the parameterization and you put them into the formula, right? So I'm not sure that will be the simple way to do, but let's find the parameterization first. That's the first method, right? So if you use R over T, this is the easy case. So I just equal to T pi T half of pi T, right? T is between 0 and 1. You can also use another parameterization, T. Let me change the other parameterization, because this is just the standard one. But for I don't want to put a pi here. Instead of pi, that's 2t and 2t and a t. Then t is between 0 and half pi. Okay, so that's also give you the parameterization for the line segment. Okay, so now the line integral, okay, is going to be the integral from 0 to 2 pi, half pi. What is f? F is going to be sine y. Okay, so let me write down the f, right? The first component sine 2t, and the second component is 2t cosine 2t. The third component is just t. So negative sine t. Okay, right? Just x. Yeah, it's a sine y, and hold on, x is 0. Sorry, x is 0. Okay, 0 times cosine 2t, and the z is going to be t. Okay, so now then dr is going to be 0, 2, and 1, and dt. Okay, not too bad, right? It's going to be the third component. It's only, you only get negative sine t dt, right? Because the dot product of the is going to be the product of the corresponding components. Just because this, I just gave an example. Yeah. So here it's going to be cosine t from 0 to pi over 2. It's going to be cosine pi over 2 minus cos 0 to negative 2. Okay. So that's the first method. It works, in some cases. It's not too complicated. The second method is you express f as a gradient of function. Okay. Well, f is going to be, we already got that, right? F is going to be x sine y, our x sine y cosine z. Okay, so this is our function. So if you know that, then this line integral is going to be just the f evaluate at the two endpoints. Okay, the first endpoint, yeah, evaluate at the 2 points. You know, the last point is going to be 0 pi pi over 2. And here is a 0 and 0 and 0, I guess, yes. Okay, so f, okay, 0 pi over 2 minus 0, 0, 0. And when x equals 0, that first term is already 0. Come on. So, yeah, it's going to be cosine pi over 2 minus cosine 0 still. Okay, so it's going to be negative again. Huh? No, it's my mistake. It's negative 1. You're right. Cosine. Yeah, it's negative 1 because cosine pi over 2 is over 0. Yeah, cosine pi over 2 is 0. I saw this cosine pi. All right, so for some problems, you cannot tell the difference between the time you spend on the problem. But if you are able to quickly find to see the vector field is conservative and find the little f, then you just need to evaluate the function at the two endpoints, okay? All right, our next problem. Evaluate this line integral. Okay. Well, C is the triangle with vertices from 0, 0, 1 to 0, and 1 of 2. All right, if the orientation is not given, usually it's counterclockwise orientation. Okay, so that means I have a 0, 1, 0, going this, and 1, 1, 2, and going down. Okay, so it's a closed curve. Line integral of a closed curve. Okay, so usually the easiest way to do is to apply Green's theorem to solve. If I do not ask you, do not tell you what method you're going to use, because if you change one single integral, double integral, this is a domain D, that's a C, right? Remember, as the Green's theorem says that P, right? This notation is actually the C and the vector field PQ and dx dy. So in other words, it is going to be just dr if it's parameterized. Okay, so this is a P, this is a F. Okay. So by the Green's theorem, this is going to be the double integral qx py dA. We change the double integral. Okay. Our function here, q x is going to be x times y, right? It's 2x times y, so it's 2 here. Minus the partial derivative of p 1 plus x squared dx. Okay. You will get 2y minus, that's going to be 0. Simple. Right? You don't need to worry about the square root. Otherwise, you have to parameterize each side of the triangle. You have 3 integrals over C1, C2, C3. It's too complicated. Even those integrals are not difficult. Then maybe you have to deal with this radical. Okay. Now this double integral to y. Simple. Right? How do you evaluate this double integral? Okay. I think we still have to find the equation for these 2 lines because you want to know where the right the upper bound for the y value for the fixed x, right? Yeah, you have to see x is between 0 and 2. Then you have to decide which y, right? And the y is between 0 and some question mark here, dy dx, right? So you have to figure it out. For the fixed x, what is the y value? Well, the y value depends on x, and it depends. It also depends on the line. These lines. So the first line is clear. Y equals 2x. The second line, I think it should be y equal to negative 2x plus some number. Okay, what is the number? Okay. When x equals 2, you should get 0. So I should plus 4. I'm pretty sure. Right? Yeah, because I have to. I know the slope is going to be negative 2, but I have to figure out what is constant. I have to put there. So it should be 4. So when x equals 2, the y value is 0. That's matches. Okay. So now I have 2 integrals, actually from 0 to 1. The y value is from 0 to 2x, 2y dy. Then x is from 1 to 2. So y value is going to be from 0 to 2, 4 minus 2x. Okay. You just break this integral in 2 pieces, right? It depends. The question mark over there depends on which interval you are on. Okay. So now you get a y squared, and here you get a y squared evaluate at the 2 endpoints. Right. Two squared 4x squared dx. And this one, the 4 minus 2x squared dx. Okay. So the next step is just to evaluate this integral. Yes. No? Any question? No? You have a question? All right. Oh, yeah, the problem is from 0. Yeah, I did not write down the exact number. It's not the same problem. The triangle, just I use it's the problem on the book. It's yeah, the triangle is different vertices. I just random pick up the points. Okay, so 0, 0, 1, 0, and the 1, 2. What? Oh, the 1. Yeah, that was 2 here. Sorry. Yeah. Otherwise, this does not look like isosceles triangle. Yeah, that's right. This is yes. Okay, 2, 0. Okay, 2, 0, 1, 2. Okay. Yeah, then the slope one is 2, other one is -2. Okay. All right, so just evaluate this. This integral would be 4 square minus 4x plus 4x squared. No, this is 4 square x. Okay, and then you find the antiderivative for each, then you solve the problem. Okay. So that is going to be 4 over 3x cubed from 0 to 1, and this will be 4x squared minus 4 squared over, no, just 4x, sorry, not 4x, minus 4x, that's squared, plus 4 over 3x cubed, and from 1 to 2. Right? So then you get answer. Okay. I think it's time for the quiz. All right, so we will continue our review class on Wednesday if you can come.